Okay, so we're going to be looking at the area of parallelograms and triangles, and I know we've looked at triangles before, but this would just be good review and maybe some different types of examples that we can come across. But let's look at the area of parallelograms. First of all, a specific type, looking at a rectangle, because that's going to help us break down the other two. And when we're talking about the rectangle, we all know from previous examples, we know the area of a rectangle is length times width, or area the area is equal to the base times the height. Okay, and we've talked about previously that if I have a rectangle, length times width, we would define the length as the longer, the longer side, and the width as the shorter side. Now, when we're talking about area in terms of base times height, that's where the definition changes slightly, but that also applies to when we're working with parallelograms and triangles. Now, the base is just some side. Usually we're talking about the bottom side in terms of our orientation, but the height always has to be perpendicular, form a 90-degree angle with the base, okay? So the height always has to form that 90-degree angle with the base, wherever that happens to be, okay? So notice in those two examples, the base forms a perpendicular angle with the height, and then the height forms a perpendicular angle with the base. But the area is still the same. It's still base times height to find the area of a rectangle, okay? So for instance, if we have this rectangle here, our area would be 6, our base, times our height of 2. And 6 times 2 would be 12 centimeters squared. In this case, if we consider our base to be 8, then perpendicular to our base would be 4 centimeters. So our base times our height over here, base times height, would be 8 times 4, which is 32 centimeters squared. And then for this example with the rectangle, it doesn't really matter what we consider to be the base. If we put this on the bottom side, could be our base, and we can consider this to be our height. So base times height, 5 times 1, would be 5 centimeters squared. So finding the area of a rectangle, we just take the base times the height. In this case, 5 times 1 is 5, so we get 5 centimeters squared. Okay, so that's the area of a rectangle. Now, a parallelogram is very similar to that, but a common mistake, this is a very common mistake. People assume if we call this, let's say the base, and this is some side D, they use C, but let's just call it the base. They assume it would be B times D over here. Well, that's not the case, because D is not the height. In fact, what we're going to see here is we can actually use a term called dissection, in which if we create a 90-degree angle, a line perpendicular to create a 90-degree angle here, in other words, a right triangle, and we were to take this triangle, and let's say we cut off this entire piece. Let's cut off this entire piece, and that term is called dissection. Take that entire piece and shift it over to here. Well, let's use the same color and shift it over to here. Okay. Notice, what do we form? So just focus on this right here. I probably went too far. Focus on this right here. What did we form over here? Keeping in mind that this is still a right angle. Well, we formed a rectangle, right? So if we move this to the other side, we now have a rectangle, and this guy would be my height. So actually, the area of a parallelogram is still base times height. We just need to determine the height of a parallelogram. So it's not B times D, whatever this side is. It's still base times the height. Okay, similar to when we were talking about a triangle, okay? And that's the argument that I just went through here. It says, if I take this piece here, notice we can move it to the other side, and that creates an equal, we're just moving it to the other side, so it's the same triangle. And then that forms our, rectangle, and we have our base times our height. Okay, so then it would have an area. So we just showed that this guy over here has an area equal to a rectangle of the same base and height. Okay, so with that in mind, we know that the area of a parallelogram is base times height, just like a rectangle. We just need to determine what that height is. Now in this example here, we are given a rectangle. We could call our, let's say our base over here is 2 and our height is 5. Then the area would be 2 times 5, which is 10. So we get 10 centimeters squared, okay? And that's for a rectangle. Now over here for our parallelogram, Okay, it's still base times height, but this guy right here is not the height. Remember, the height has to be perpendicular, form a 90-degree angle, with our base. So if we're calling 15 the base, this would be the height of the parallelogram because it forms a 90-degree angle with our base. Now, what we need to do is use the given information in order to determine what that height is. Now, there's a couple of different ways we can look at it. I'm going to show you a couple of different ways. We could use our sine, cosine, and tangent ratios to help us. For instance, let's use a different, well, not that one. Let's use this one. If this is our angle here, our reference angle, then h would be the opposite side, and 12 would be the hypotenuse of this right triangle. So if we're dealing with opposite and hypotenuse, which of those ratios are we talking about? Sine. So if we take the sine of 30 equal to the opposite side, which is h, over the hypotenuse is 12, we can determine what the height of this parallelogram is. Multiply 12 to both sides. In our calculator, we could take 12 times the sine of 30, and it comes out to be that the height is 6. Okay, so this guy right here is equal to 6. Now, another way we could determine this, that's one way to think about it. Another way to think of this is if this is 30, this is 90, doesn't that mean that this guy has to be 60 degrees? Yeah, it's a 30, 60, 90, right? So remember, the hypotenuse is always double whatever the shortest leg is. Okay, so the hypotenuse, if we're going back to our 30, 60, 90 degree triangles, this guy was always double whatever the shortest leg was, which in this case happens to be our height. So if it's double the height, that means the height has to be 6, because 6 times 2 is 12. So that's just another way to look at it, but we still get 6. So with that in mind, our area here is the base, which is 15, times the height, which is 6, and we multiply 15 times 6, and we get the area is 90 centimeters squared. Okay? Then in our last couple of examples here, okay, we have this parallelogram. Notice, again, we have a parallelogram, and it's saying this piece, don't be confused, this piece is 3, and this piece right here is 12, okay? So that means the entire base is what? What's the entire base? 15. So our entire base is 15 centimeters. We need to find the height. Well, the height, again, is this perpendicular to our base. It's forming this 90-degree angle here. So our height here, notice, they give us the short leg and the hypotenuse. What's nice about that is we have a theorem that we can use to help us to find the missing side. What theorem is it? The Pythagorean theorem. So if I let 3 be A, h be B, and 5 be C, then in our theorem we'd have 3 squared plus h squared equals 5 squared. Then all we have to do is find h. So we have 3 squared, which is 9, plus h squared equals 25. Subtract 9 from both sides. And then we get h squared equals 16, square root both sides, and we get h equals 4. So the height is 4. Okay, and that's kind of what they're showing here too. And so with our base and our height now, we have 15. So the area is 15 times 4. In this case, 15 times 4, we get 60 centimeters squared. Okay, so the area of our parallelogram is 60 centimeters squared. Now, sometimes you might come across a figure like this where we want to use that idea of dissection and break it into smaller pieces in order to find the area. In other words, break it up into smaller parallelograms, whether that be rectangles, squares, whatever. So if this is the case, notice this side is 7.5. This guy is 10. Then we have this guy is 2. And notice there's one tick mark over here, so this also has to be 2, okay? Then let's just kind of fill in the missing information, okay? Well, if the top value over here is 10, okay, and we know that this guy over here at the bottom is 2, then 10 minus 2 should give us, let's use this color, should give us this guy, right? 10 minus 2 should give us that guy. So if that's the case, 10 minus 2, we'd have 8 centimeters. Okay, so we know that guy's 8 centimeters. Now over on the other side, our red side, 7.5 centimeters. Notice, what color have I used? This guy. This guy over here is 2 less than 7.5. So wouldn't that make that 5.5 centimeters? Yeah, 7.5 minus 2. So we have 5.5 centimeters. So now we kind of have all the sides and we can start to kind of break things down. Well, the way I want to break it down, I'm going to break it apart here, and I'm going to form 2 rectangles, okay? So my top rectangle, my base all the way across is 10, and my height, my height is 2. Well, base times height, 10 times 2 is 20. So the area of this guy is 20 centimeters squared. Now my other guy, notice, I cut it off right here. So my height is 5.5, and my base is 2. So my base times my height, 2 times 5.5, we get 11. Okay, we get 11. And now I have the area of the 2 rectangles. Okay, so I have my area of the 2 rectangles, and what we need to do is add those 2 together. So we're going to take 20 plus 11, add those 2 together, and we get 31 centimeters squared. Okay, so that would be the area of this figure here. Okay, and we'll do those in class. Now, just a reminder for the triangles, and we've kind of done this before. Remember, the area of a triangle is base times height divided by 2. Now, the reason for that, as we showed earlier, is if I take a triangle where we have, in this case, a 90-degree triangle, a right triangle, and we have our base times our height, if we duplicate that triangle, in other words, we're going to double the area of triangle 1 by 2, what we can do is we can create a rectangle with those 2 areas. Well, what do we know about the area of a rectangle? It's base times height. Well, this triangle is half of that rectangle. It contains half of the area. Why? Because those 2 triangles have the same area. In other words, it's double one of the triangle's area. So the area of this rectangle is base times height, but then the area of the triangle is half of that. So the area of a triangle is half base times height. Or another way to look at it, if we had, let's say, a different looking triangle here, if we duplicated this area here, and we call this 1 like they do at the bottom, and then we put that same triangle here, that area is now doubled, and we create a rectangle there, okay? Then if we duplicate the area of this triangle and put that triangle here, we have now doubled that area. So the total area of triangle 2 is now over here, and we have twice the total area that we had before. But notice what we create here is we create a rectangle. Well, the area of a rectangle is base times height. Well, notice we doubled the area of 1. We duplicated that area, so now we have double that area of 1, and now we have double that area of 2. So in the original figure, we had half of that total. Okay, so we had half of that total. So the rectangle is area of the base times the height, but our triangle is half base times height. Okay, and we've done some of these examples before, but it doesn't hurt to go back and review it. So if I want to find the area of this triangle, notice they give us the base over here is 9, and they do give us the height, which is perpendicular, which is 4. So the area is 1/2 times the base of 9 times 4. Okay, now there's a couple different ways you could do it. We could take 9 times 4, which is 36, and then divide that by 2, and that'd give us 18 centimeters squared. Okay, so however you want to multiply that out, 1 times 9 times 4, and then divide by 2, or just 1/2 times 9 times 4. It doesn't matter. You're all multiplying. It all gets multiplied together. So we get 18 centimeters squared. And then in this example, notice they don't give us the base, but they do give us the height, which is perpendicular to our base. However, it is nice, though. This is a right triangle, and they give us the hypotenuse of that triangle. So we can find this missing side. If I let this be a, then I'd have a squared plus 8 squared equals 10 squared. And then I can find my missing side a. But notice, isn't it going to be the same measurement over here? Yeah, so once I find A, I'm really finding both of those pieces, and together that's going to give me my base. So A squared plus 8 squared, which is 64, equals 10 squared, which is 100. So we have A squared, subtract 64 from both sides, and we get 36. Square root both sides, and we get A equals 6. So this is 6, and this is 6. But we want the length of the entire base. So if both of those are 6, what's the length of the entire base? 12. So then in our area formula, our area equation, we have 1/2 times our base, which is 12, times our height, which is 8. Okay. And again, we can multiply this in different ways, but 12 times 8 is 96. And then if we divide that by 2 or multiply that by 1/2, we get the area is 48 centimeters squared. So 48 centimeters squared. Okay. Then in this last example, again, there's a couple different ways we can think about this one. I'm going to show you both ways. What we're needing to find here in this example here is let's just do the 3069. We already did the sign. Let's just do one of the ways to save us some time. So notice this is going to be a 30 degrees. This is 90 degrees, and so this has to be 60 degrees. So let's just use the relationship that we know from the ratio of the different sides in order to find the missing sides, okay? Well, in a 30, 60, 90, the hypotenuse is always double the shortest leg. So the shortest leg here, if I take 12 divided by 2, my shortest leg should be 6. And we know from the previous example that we did with 30, 60, 90, the next smallest leg, or I guess you call it the long leg because we're not talking about the hypotenuse, the long leg is the short leg times the square root of 3. So it'd be 6 square root of 3, okay? So my short leg is 6, and my long leg is 6 square root of 3. I decided to go this route since that's what they show here, okay? And so since we have that example given to us there, our base times our height times 1/2, we have 1/2 times our base of 6 times our height of 6 square root of 3, okay? And if that's the case, we have area is equal to 1/2. Well, 1/2 times 6 is giving me 3, and then we have times 6 square root of 3. Okay, so we have 3 times the 6 square root of 3, and so we get the area is equal to 18 square root of 3 centimeters squared. Now that would be the exact answer. You could multiply that in your calculator and see what you get there, but we get 18 square root of 3 centimeters squared. Okay.